Back in 1831, Englishman Michael Faraday made a shocking discovery. By passing a magnet through a coil of wire, he was able to create an electrical current. He called this phenomena electromagnetic induction, and it sparked him to build the first electric generator. Thomas Edison was one of the greatest inventors that ever lived. Not only did he perfect the light bulb and create the phonograph, but his Pearl Street station was the world's first power plant. By combining different technologies, he literally took America out of the dark. Electricity, what a concept. Here it is.
Hey, Dad.
Hey, Dr. Dad.
Hey, guys. What's up?
We're having a little trouble with Freddie's truck.
Oh, yeah? What's the matter, Freddie?
Well, it only goes in reverse and it doesn't make any sound, but it still works, see?
Well, maybe it's got something to do with the batteries. Let me check it out for a second.
There you go.
You know, motors are kind of weird. If you don't have the batteries in exactly the right way, they behave strangely. Yeah, that's it. We got a plus here, and this last one in here, it looks like it was turned around. If I reverse it, let's see what... Whoa! I guess it works now. That should do it. Yeah, you always have to be careful that the batteries are in the right way when you got something with a motor.
I don't understand. Why should the battery make a difference to the motor?
Well, it has to do with electromagnets and how motors are made. And if you got a minute, I can actually show you, do an experiment or two. You know about electromagnets, right? Have you done anything with them in school?
Is that where you unwrap a paper clip and then you wrap it around a screwdriver?
Well, that's part of it, to make a coil, yeah. And what else? What else do you need in an electromagnet?
A battery?
A battery, yeah. You need something to make electricity. And we got enough stuff right here we can build it. You know where the screwdrivers are, right, Olivia? You want to get me one?
Okay.
And Karen, why don't you get the battery over there? And this wire looks like it's just about the right size. Take a couple of clips. You know, the guy who found this out was a Danish scientist by the name of Hans Christian Ørsted, and he lived back, he did it around in 1820. And the interesting thing is that he hadn't a clue what he was doing. You know, it was one of those great moments in science where you just basically messing around with something, and then you make a discovery, and then you got to figure out what you did. And he came up with making an electromagnet the first time. We call this electromagnetic induction, which basically means taking something that's non-magnetic and making it a magnet by using electricity. Okay, there's our coil. All right, you want to hold on to that? And Karen, hook those two onto the battery. And I'll hook this one right up here. And we'll hook this one over here. Now, that should make it a magnet. Why don't you try it on the paperclip there, Olivia? And sure enough, all right, now it's working. And if we disconnect it, the paperclip falls off, okay? And we'll put it back on, not connected, and you see it falls off. And that's electromagnets are nice because they're a temporary magnet. You can turn them on and off when you need them. Now, to make a motor, what you need is two kinds of magnets. You need an electromagnet and something called a permanent magnet. And this horseshoe magnet will work. Now, do you know about the law of poles? Has anybody ever talked to you about magnetic poles?
Is that when opposites attract and the same repel?
Exactly. If you ever look at a magnet, usually they have labels on them. This one says north here. That means this is the south pole. So if we brought a north and a south pole together, opposites, they're going to come together. But if I brought a north and a north together, what do you think is going to happen?
It's going to repel.
It's going to push apart, okay? Now, what I need is a coil. And I got, actually, this is part of an old motor right here, so we can use this. All right, now I'm going to put the magnet in. Watch what happens. As I hook in this magnet, the coil is going to line up, okay? Now, what's happening is the north end of the coil, even though it's not turned on yet, this is coming and getting attracted to the north end of the magnet. This is the south end of the coil. Now, Olivia, if you hook up the motor here, what I want you to do is hook up the clips to the two ends of the motor, and let's watch what happens. All right. Now, there it goes. The motor starts spinning. That's all right. You just touch it right on there. The motor starts spinning. Okay, now what's going on is that when you hook up the electricity, the thing that was the south end becomes the north end. So when you get two norths together, what do?
They keep repelling.
They keep repelling. And what the motor does, it just keeps reversing that, so it keeps repelling. Now, to answer your question, Karen, what I want you to do is disconnect the battery a second. Okay, now watch, disconnect it. Now it's spinning this way, right? Now I want you to reverse them, okay? Now this is like turning your battery backwards in the truck, Freddie. Now watch what happens to the motor. Now it's spinning backwards, okay? Now with something like that truck that has a lot of electronics in it, it just doesn't know what to do with the electricity. It's going the wrong way, so it gets confused and the sound effects didn't work, and it just ran backwards. Now, the interesting thing about motors, which I really like, is that you could take a motor and you could actually use it to make electricity, and we could turn it into something we call a generator. And if I take a meter here, this is a current meter, it will measure electricity, and we'll clip it on. Now, here I've disconnected the battery, okay, so there's no power source in here. All right, now Olivia, what I want you to do, keep an eye on this thing.
Okay.
Just give it a spin. Just give it a spin.
It's moving.
It's moving, all right? What you're doing is you're generating electricity there. Now, as the faster you turn it, right, the more electricity you make. So you can run a motor backwards, take the energy out of it and run it backwards, and it will actually be a generator.
So that's how a motor can run in reverse?
Yeah, and it also, if you turn this thing backwards. Now, what do you think would happen if I spun this way?
Well, the meter goes backwards.
Yeah, so what we have is same thing. We can reverse it. So just like the reversing the battery, reverse the motor, reverse the generator, spin on the generator, reverse the current direction. Now, I have a friend, Joe, that works out at Big Cajun, and I was out there last week at the power plant. In fact, if you want, we can take a look at what some of the stuff I found out.
Okay.
All right, great. Okay, Joe, so is this where it all gets started at Big Cajun too?
Yeah, Steve, the coal that you see inside at the docks, that coal is mined in Powder River Basin in Wyoming, and it's shipped from rail from Wyoming down to St. Louis, where it's offloaded on the barges down to Mississippi to our unloading facility right here.
So you basically take all the coal, it comes from Wyoming. Okay, so now here you unload it. Now what, it comes up the conveyor and you stockpile it here?
That's correct.
Now how much coal do you burn in a year?
Oh, a little over 5 million tons.
5 million tons, right? And how much do you keep in reserve?
About 1 million tons.
1 million tons. Now why do you keep that much in reserve? Is there any, I mean, you know, is there a coal shortage or something? Or?
No, it's not necessarily a coal shortage, Steve. In the event, let me give you an example. A couple of years ago, when the river was extremely low, we couldn't get barges down to Mississippi, so we had to rely on the reserves we had here in storage to keep the plant running.
So you always make sure you have enough because you don't want to shut down the plant for any reason if you don't have to.
That's right.
That's the key. You got to keep it running all the time. All right, well, this looks pretty impressive from up here, but why don't we take a look down by the generators now? We can head down, is that all right?
That's fine.
Okay, great. All right, Joe, so what's happening here? Where are we?
We're on the burner level of the boiler. This is where the boiling process takes place, where we convert the water to steam.
So the coal is fed in right here and then it's burned?
That's correct.
Okay, can we look inside?
Sure, we can take a look.
Okay, great. So how hot does it get in there, Joe?
2,600 degrees.
Oh, that will cook some marshmallows, boy.
Oh, yeah.
So the boiler makes the steam comes down, gets into this yellow building, which is the turbine. Now, what's the turbine?
The turbine is turned by that steam, and it's connected to the generator.
Okay, so the turbine's like a propeller that the steam is pushing, and then the generator is just turning, and that's finally where we get the electricity.
Exactly.
Okay, then the electricity goes from the generator and goes to the switch yard out here.
That's a 500 kV switch yard.
And then you can spread it all over wherever Cajun Electric
That's correct.
feeds. So you can spread it all over the South. All right. So Joe, now we're in the control room. So this is sort of like the nerve center of the whole place.
And this is the heart and soul right here.
So now you can control everything, the whole power plant from in here?
Yeah, with the help of a control room operator in this center and outside operators, we can operate the units from in here.
So he's sort of like the captain, and he just sends out the information and then they work back and forth.
That's correct.
Okay. Now, in terms of the amount of power that comes out of here, you were telling me about the gauge here. That's 483 megawatts of power. That's 483 million watts of power?
Yes.
That's like 4 million light bulbs if you put it out at once. That's an amazing amount of power. Now, when you control all this to feed it out, it goes out into a power grid. Now, how does that work with a grid?
It's all connected. It's an interchange, and we leave the switch off. We produce power here, and it goes out into a grid, and it's distributed throughout the southwest power pool as needed.
So different power utilities, individual utilities, then will buy and sell power back and forth to each other like it's a product. So you're sort of like a power wholesaler.
Right.
And you just send it out, supply and demand. I guess when
Yes,
they need
and
it.
they have to equal each other at all times.
Now, do you ever make too much power, or is it
No, the two have to balance.
they're always balanced, and you really can't store it in any way, huh?
Right.
So you just as it's needed, it just comes out. That's an amazing concept. So what'd you think about the power plant?
That was cool.
Pretty impressive, huh?
Yeah, I can't believe how big their generators were, how hot it got.
I can't believe how much coal they use.
Yeah, they got to keep it going to put the power out. And in fact, you know, we didn't see it there, but I have a model of a generator here that should shed some light on what's going on here. Now, it's the same thing that they had. That was in that big yellow building there. We have the magnets here, and we have the coils in here. So if you give it a turn, why don't you give it a turn, Karen? Let's see if we make some electricity here. And you can see the bulb is lighting up. Now, the faster you turn it, it's a little bit noisy. The faster you turn it, the more electricity you make. Freddie, you wanna try a go at it? Now, in power plants, they could use anything to turn the crank. They can use steam, they can use water, they can use nuclear power to make the steam. So there are lots of different ways to turn the crank. But I bet you guys, if you thought about it, could come up with your own generator right now. Because there are a lot, really is not too much difficulty to building one. What do you think we're going to need if we're going to build the generator? What do you got an idea?
A magnet?
You're going to need a magnet. Okay, we got the magnets. And what else are you going to need?
Some wire.
You definitely need wire. And what else? What do you think, Freddie?
A little piece of metal to hook it up to.
Yeah, something to hook it up to use it. So we have some stuff laying around here. We need something to wrap a coil of wire around. Do we have something back there? That will do
Will
it.
this do
All
it?
right. Paper tube. And we got a magnet stuck right on there. If you want to go get that magnet, Karen. And I'll tell you what, Olivia, you can do our coil wrapping right here. I'll start. This wire probably will be long enough. So you just wrap it around there. I'll hold the end, and I'll let you do it. And you want to try to get it as straight as you can. Now, the thing about a generator is we're just working with it here. We saw that the speed is the thing that controls it, but there are also a couple of other controls. Okay, that's good.
Okay.
All right. All right, now, Karen, why don't you just tape that across? All right, now hold that, and I'm going to hook this thing up to our meter again, and let's see what we can do in a way of making electricity. Now, this coil is a lot shorter than the coil we have here on the generator. Okay, why don't you hold that up and let Karen do some magnet movement. Just push it in and out. And if you look, do you see on the thing? All right, as you push it in, it goes one way and then the other way as you move the magnet back and forth. Now, how do you think you would make this generator more powerful? What could you do?
If you had a bigger magnet, or maybe moved it faster.
Okay.
Pushed it farther in.
Pushed it farther in, moved it faster, bigger magnet. How about the coil?
Maybe a bigger or more powerful wire.
Yeah, the more wire you have, the longer the coil, the more you're going to generate. So that's basically the story of generators and motors. They're really the same thing. You just have to turn them backwards and they will do the same thing. So now, that's what I want you to work on. See if you can come up with a better generator. That's your challenge. And you could use a paper towel tube or anything that's longer. You're going to need a lot of wire and a lot of winding. But you'll find you can make a pretty good generator. So there's your truck, Freddie. I think we
thanks for
solved that
fixing it.
problem. No problem. And you guys have a good day.
Okay,
And we'll see you
thanks,
later.
Dad.
All right.
Bye, Dr. Dad.
Bye.
I'll go back to my chicken here. Still dead.
To build your own electromagnet, all you need is some insulated wire, a flashlight battery, and a big steel nail. Cut off about 2 feet of wire and make sure you strip the insulation off the ends. Wrap the wire around the nail so it forms a tight coil. Connect the ends of the wire to the 2 ends of the battery and presto! You have an electromagnet. Be careful not to leave the wire hooked up too long, and don't use anything bigger than a D-cell.